So in this video we're going to go over integrals. So we're going to start by drawing a function. So let's say we have the function y equals x squared, and we want to find the area under this function from x equals 2 to x equals 4. So this is what integrals are about. So what we're going to do is break the area under this curve into the area of 4 equal rectangles with equal width. So the width of these rectangles right here at the bottom is going to be delta x. Okay? So these rectangles aren't going to go all the way to the curve. So the rectangles are going to look something like this. So it's not the perfect area under the curve, but it's a good approximation. So they have width delta x. So what is delta x? Where it would be 4 minus 2 over 4. Since it's between 4 and 2 right here. And there's 4 rectangles. So it would be 4 minus 2 over 4, or 1/2. So delta x is 1/2. So that means we can fill in what these lines are. So this one would be 2.5 because delta x is 1/2, so it would be 2 plus 1/2. This one would be 3, and this one would be 3.5, right? So 2.5 is that line, 3 is that line, 3.5 is this line. So now we know the width of these rectangles. Now, what is the height of the rectangle so that we can find the area? To find the area, we need to know the base, which is 1/2 for each of these rectangles, times the height. Well, as you can see, the height is always changing. So we're actually going to only take the height of this left side of each rectangle. So I'm coloring in the left side of each rectangle. So what is the height of the left side of this rectangle? Well, since it's y equals x squared, and it's at x equals 2, then the height must be 2 squared, or 4. The height here must be 2.5 squared, so 5/2 squared, or 25/4. The height here for this rectangle must be 3 squared, or 9. And then the height of this last rectangle must be 3.5 squared. 3.5 is the same as 7/2. So 7/2 squared is 49/4. So those are the heights of the rectangles. So as you can see, the height of each rectangle is the function. So we're plugging in the x value into the function. So now we can find the area by adding up the areas of these rectangles right here. So if we add up the area of this one would be 4 times 1/2. So the area of this one is 2. The area of this one would be 25/4 times 1/2, which would be 25/8. The area of this one would be 9 times 1/2, or 9/2. And the area of this one would be 49/4 times 1/2, or 49/8. So we're going to add this up to find the area. So 2 plus 25/8 plus 9/2 plus 49/8. So this equals 16/8, which is 2, plus 25/8 plus 36/8, which is 9/2, plus 49/8. So The area under this is whatever this thing equals. So all we did was we broke it up into rectangles, and we found that the height of these rectangles is the function, and then the width of each rectangle is 1/2, because it would be 4 minus 2 over 4, because there's 4 equal rectangles between these two numbers. So that is called a Riemann sum. It's called a sum because we're adding up all the areas of the rectangles. So the way we can write this is, let me erase this. Let's call the width of each rectangle delta x. And then the height, remember, it was f of that rectangle. So what we're going to do is I'm going to draw that picture again. And now let's say it's any function, so y equals f of x. It doesn't have to be y equals x squared, it's any function. And we want to find the area from A to B. I'm going to break it up into n number of rectangles, so it would be b minus a over n. So we don't know how many rectangles we want to break it up to. We're going to break it up into n rectangles. So the width of each rectangle would be b minus a over n. So that equals delta x, or the width of each rectangle. And then, so there's going to be n rectangles. So there's going to be n minus 1 lines. So this would be x1, this would be x2, all the way to xn. So I'm just doing 3 just to make it clear that if there's 3 rectangles, you only have to draw 2 lines between A and B to make them. See, I just drew 2 lines, but there's still 3 rectangles, right? So that means that this height over here is equal to f of x1. This height right here equals f of x sub 2. See, it's always, so it's always one, the highest rectangle is always one less than how many rectangles we want, right? So if we wanted 3 rectangles, it would only go up to 2. So we can write this as a sum. So we write it as the sum from I equals one to n of f of x sub I minus 1 times delta x. Now delta x equals b minus a over n. So we're going to replace this with b minus a over n. So what this means is we're adding up all of these things from I equals 1 to n. So let's say we had, this curve was y equals x squared. So this would be, and we wanted it from 4 rectangles, so it would be the sum from I equals 1 to 4 of f of xi minus 1. Now f of xi minus 1 would be xi minus 1 squared, since f of x is x squared. So xi minus 1 squared times b minus a over 4. Now remember, we wanted to find the area from 2 to 4, so it would be 4 minus 2 over 4, or 1/2. So what does this mean? So let's take I equals 1. So it would be x0 squared times 1/2. There is no x0 right here, so that would be 0. And then it would be x times 2 minus 1 squared, so x sub 1 squared times 1/2. So remember, x sub 1 was 2.5. So 2.5 squared times 1/2, then this one would be 3 squared times 1/2. This would be 3.5 squared times 1/2. So as you can see, we're just adding up the areas of all of these rectangles. So it's the sum from I equals 1 to n of f of x sub I minus 1 times delta x. Now what we do is we take the sum as the number of rectangles goes to infinity. So now we have an infinite number of rectangles. And if you have an infinite number of these rectangles, it's called an integral. So what we do is if n goes to infinity, we call this the integral from a to b of f of x dx. So what this is this is the area under the curve from a to b. And we call it the integral from a to b of f of x dx. So dx is an infinitely small width for the rectangle, and f of x is the height of each rectangle. And we're taking an infinite number of rectangles and adding them up. So it's called the integral from a to b of f of x dx. So this is an integral. And the cool thing about an integral is that it's the opposite of a derivative. So what that means is, so if you have a function f of x, if you take the derivative of that, you get f prime of x, right? So what this means is that the indefinite integral means so we're going to take the indefinite integral of f prime of x. So indefinite means there's no boundaries from a to b. So what it says is that the integral of f prime of x equals f of x. So the integral is the opposite of the derivative, just like subtraction is the opposite of addition. So this is finding the derivative and taking the integrals called the antiderivative. Okay? So let's do an example of this. So let's do the integral of 2x. So what function, if you take the derivative of it, you get 2x? Well, that would be x squared. Because if you take the derivative of x squared, you get 2x. So the integral is like the opposite of the derivative. Okay? So that's the integral. So it's the opposite of a derivative. So now we're going to go over something called the fundamental theorem of calculus. So what we do is we define capital F of x to be equal to the integral from 0 to x of f of x. So what we want to do is find the integral from a to b of f of x dx. So we want to find the area under the curve from a to b, and we define capital of f of x to be the integral from 0 to x of f of x. Okay, and what it says is that the area under the curve from a to b of f of x equals f of b minus f of a. So let's do an example of this. So let's say we wanted to find the area under the curve from 2 to 4 of 2x dx. So what would be the area under the curve 2x from 2 to 4? Well, it would be f of b. So f of b means we're plugging in b into this thing. So in this case, b is 4, so it would be the integral from 0 to 4 of f of x, which is 2x, minus the integral from 0 to 2 of 2x. Now, what is the integral of 2x? So what function, when you take the derivative of it, you get 2x? Well, that function is x squared. So basically, if you take the integral, so it's going to be the integral of 2x evaluated at 4. So it's going to be 4 squared, because x squared is the integral of 2x, minus 2 squared. Which is the integral of 2x evaluated at 2. So it would be 16 minus 4, which equals 12. So the area under the curve from 2 to 4 of 2x equals 12. Okay? Now let's do another example. We're going to take the integral from 1 to 2 of 3x squared dx. So that's going to be equal to the integral from 0 to 2 of 3x squared minus the integral from 0 to 1 of 3x squared. So what's the integral of 3x squared? So what function, when you take the derivative, you get 3x squared? Well, that's going to be x cubed. So this thing is actually going to be 2 cubed, because 2 is the thing that the top of the integrals is, and minus 1 cubed. So basically we're plugging in these numbers. So we're subtracting the smaller number from the bigger number in the antiderivative. So 2 cubed, because the derivative of 3x squared is x cubed. So 2 cubed minus 1 cubed, which is 8 minus 1, which equals 7. So the area from 1 to 2 of the function 3x squared equals 7. So this is the fundamental theorem of calculus, and that's what integrals are used for. So this is going to be it for this video, and I'm going to make another video soon about more about integrals. Hope you like this video.